morning friends, beloved students. Welcome back to C level physics. Myself Srinivas, known to be BS Rao. Today we are going to start one new chapter. It is nothing but motion in a plane or motion in 2D. It's very easy and most important as far as NEET mains JEE advanced are concerned. Okay, so let's move on to topic. See, what is the chapter? Motion in 2D or motion in a plane. What is meant by motion in 2 dimensions? Means here particle should move in a plane along any curved path other than straight line. Then it is said to be motion in 2D. So what's the point here? Particle should move in a plane. Particle should move in a plane in any curved path. Any curved path. Okay. Other than straight line. Other than straight line. Right. So then it is said to be motion in 2D or motion in a plane. Of course here, see. Suppose this word plane, am I right? XY plane for example. Here particle moves along curved path line. So then it is an example for motion in 2D or motion in a plane. So this word motion in 2D, right? 2D. So this word x-axis, this word y-axis. If at all particle moves in the same plane along a straight line, then it's not at all motion in 2D. Why? Because here path is a straight line. See here, x-axis, here y-axis. So it's what xy plane. The particle moves along straight line like. Now it's not an example for motion in 2D. Why? Because here the path is a straight line. So as it is straight line, it is example for motion in a straight line or motion in 1D only, right? So this is what 1D only, right? So what is the criteria? Here particle should move in a plane in any curved path other than straight line. Then it is said to be motion in 2D or motion in a plane, right? Okay. Now here we have to talk about trajectory. Next point, trajectory, right? Trajectory means nothing but path followed by moving object. So path followed by moving path or object, right? So what is meant by trajectory here? Trajectory means path followed by moving particular object. It should be trajectory. So basically trajectory means path only, right? Path. Okay, next point here. Equation of trajectory. Equation of trajectory. Equation of trajectory. See here, equation of trajectory in the sense it's a mathematical expression showing x and y position coordinates, how they are changing. See here, it's a mathematical equation showing how x and y position coordinates changes, right? So an equation showing how x and y position coordinates of particle changes in its motion is said to be equation of trajectory. For example, x position coordinate is a function of time. Am I right? Y position coordinate also function of time. So individually, both x and y position coordinates changes with the time as shown. X equal function of t, that is f of t, and y also function of t. Suppose if t is eliminated in both expressions, for example, see y equal to function of t is eliminated by writing x, f of x, then this becomes equation of trajectory. Equation of trajectory. Equation of trajectory. Right? So what is my equation of trajectory? If x coordinate is a function of time and y coordinate also a function of time, then if y equal to f of x, see here this expression showing that how y changes with x, means y is a function of x, right? Here this expression not showing variation of y and x with the time. Individually x and y changes with the time, but here this is what one modified expression, right? Both are related such that without any involvement of time, then that expression is said to be equation of trajectory. Equation of trajectory. Okay, right? Now let us see one example for 2D motion. One example. Suppose one particle moves in xy plane as shown. XY plane as shown. See one example here. This is what XY plane, right? This is what XY plane. Okay, here particle moves along curved path as follows. Right? This is what one curved path as follows. Right? Suppose I want to specify its motion somewhere here at this point. At this point, see? At this point I want to specify its motion. At this point, what is its velocity? Instantaneous velocity along tangential v. Am I right? Now same can be resolved into two components like that. One is along x-axis, that is vx. Another one is along y-axis, that is vy. Am I right? So vx, vy. Here instantaneous velocity, otherwise net velocity, making some angle alpha with vx, otherwise horizontal. See, here instantaneous velocity making some angle alpha with horizontal or px. See, this is what x-axis, this is what y-axis. So here particle moving in xy plane as shown along curved path, right? So at some point, at some instant, at some point, its instantaneous velocity is located somewhere here, right? So which can be resolved into two components. One is vx along x-axis, another one is vy along y-axis as shown. Right? Same only I am writing somewhere here. See, this is what vx, this is what vy. This vy is joined somewhere here at this side. So that is what vy. Now this v can be written somewhere here. V. So all vx, vy and v forming one right angle triangle. See here, what is the angle? 90 degrees. So net velocity, otherwise instantaneous velocity, is on hypotenuse side and vx, vy on other two sides, forming one right angle triangle. Right angle triangle. Now usually v is nothing but root over vx square plus vy square. Hypotenuse equal root over side square plus side square. That is root over vx square plus vy square. Right? Now what is vx, what is vy? How to get vx and vy? Means horizontal component of velocity, vertical component of velocity, forming together net velocity. See, vx and vy forming together v, net velocity. Now we know that v equal to u plus at. V equal to u plus at. Right? Now take the expression along x-axis, that is vx equal to ux plus ax into t. Right? Vx equal to ux plus ax into t. Okay. Similarly, vy. Vy means v equal to u plus at. Once again, take the expression along y-axis, that is vy equal to uy plus ay t. So t is absolute. You are not supposed to write tx or ty. Why? Because that is absolute quantity. Any direction. It has no direction in fact. So, okay. So vx equal to ux plus axt, vy equal to uy plus ay t. These are the components. These two components can be written like that. So here, see Vx equal to Vx plus xt is nothing but one linear equation. This is also one linear equation. Means this is one dimensional equation. This is also one dimensional equation. Okay, these two together forming net velocity for this particle, which is in 2D. So that means to say that motion in 2D is said to be combination of two linear motions which are along mutually perpendicular directions. See, Vx is one linear motion, that is one dimensional motion. Vy also one dimensional motion along y-axis. This is for x-axis, this is for y-axis. So both together forming net velocity of that particle which is under 2D motion. So what I am saying means here, motion in 2D is nothing but a combination of two linear motions which are mutually perpendicular to each other. So this word along x, this word along y, all together forming net velocity for that particle which is in 2D. So 2D is the combination of two linear motions which are mutually perpendicular to each other. One is along x-axis, another one is along y-axis. Right? Okay. Now, what is here? V equal net velocity at this position or at this instant, at any instant t, is given by root over Vx square plus Vy square. Now, what is Vx here? That is Vx means Ux plus Axt whole square plus Vy means this one, that is Uy plus Ayt whole square. Right? So this is what net velocity of that particle which is in 2D. Right? Now here, that net velocity or instantaneous velocity making some angle alpha with horizontal or Vx. What is that alpha? How to get means take tan alpha. Tan alpha. See here, what is this angle alpha? Angle made by net velocity with horizontal or Vx. So tan alpha can be written as opposite side by adjacent. That is Vy by Vx. Right? So Vy means this one, Vx means this one. That is Uy plus Ayt divided by Ux plus Axt. Now what is alpha here? Alpha represents the direction of motion of that particle which is in 2D at this instant, right? So alpha usually represents the direction of motion. Direction of motion. Right? Alpha represents the direction of motion of the particle at that instant after t seconds. When it starts its motion somewhere here. See, this is the instant t equal 0, means initial instant when actually motion was started here. Right? After t seconds, this is the position of the particle. Right? At that instant, what is the direction of motion of that particle means we have to specify angle made by net velocity with horizontal or Vx. Right? Okay. Now coming to displacement or position vector. Right? After t seconds, this is the position of the particle. Now a line segment joining from initial position to final position. Nothing but position vector or displacement vector. See, this is what position vector. This is what position vector. This is what position vector. A line segment joining from initial position to final position. This is what R bar, otherwise S bar. R bar or S bar. Now this is what vertical displacement covered. Now this is what horizontal displacement covered. Right? At that instant. So after a time t, this is the horizontal displacement covered, this is the vertical displacement covered. Now let it be Sx, displacement along x-axis after t seconds. Now this is what displacement along y-axis, Sy. Now this is nothing but net displacement net displacement. So same only writing somewhere here. See, this is what Sx, this is what Sy. Now this is what S, net displacement, otherwise magnitude of position vector, right? So R bar, otherwise S bar, R bar, otherwise S bar, R bar, otherwise S bar. Hypotenuse is position vector, right? A line segment joining the position of the particle from its initial position is the displacement vector, otherwise position vector. This is the displacement, otherwise position vector. So this vector also has two components. One is along x-axis, another one is along y-axis, right? So means net displacement by that time when it reaches this position also can be resolved into two components, Sx and Sy, right? Now what is Sr, otherwise R, means root over Sx square plus Sy square, Sx square plus Sy square, right? Sx square plus Sy square. Now this displacement makes some angle pi with horizontal or x component of displacement. See, net displacement or position vector making an angle pi with horizontal or x component of displacement. Now what is this pi means? Angle of elevation. Angle of elevation. Pi means angle of elevation, right? So after some time t, if you want to specify angle of elevation, how to specify here? Tan pi equal Sy by Sx, vertical displacement by horizontal displacement. You want to specify direction of motion after t seconds, right? Then tan alpha equal to Vy by Vx. This is in terms of velocities, but here it is in terms of displacements, right? That's what angle of elevation from above the ground or horizontal, right? Now what is S? S equal to, we know that S equal to ut plus half at square, usual formula. S equal to ut plus half at square. Same can be taken along x-axis, initial Sx, uxt, axt square. Okay, Sx equal to uxt plus half axt square. Nothing but it's not a new formula. We are very familiar with that formula, S equal to ut plus half h square, but applied along x-axis. Why? Because here 2D motion is combined motion of two linear motions or two 1D motions which are perpendicular to each other. So take separately well-known equations. One is along x-axis, another one is along y-axis. Again, S equal to ut plus half at square. Now this time Sy, Uy, F. So same formulas, but one is along x, another one is along y. Why? Because after t seconds, this is the position. So particle covers through Sx along x, covers through Sy along y-axis, such that we have net displacement S, otherwise R, right? But these are nothing but components. X component of displacement, here it is y component of displacement, collectively forming net displacement S, otherwise R, such that root over Sx square plus Sy square, as per Pythagoras principle, right? Now S equal to root over Sx square plus Sy square, right? What is Sx mean? This one. This one. What is that? Uxt plus of axt square, right? Whole square, right? Plus Sy square. Sy means this one. That is uyt plus of ayt square whole square. So this is what net displacement. Now how to find pi? Angle of elevation pi equal to, that is otherwise tan pi. We know that tan pi equal to Sy by Sx. Sy by Sx. Sy means this one, Sx means this one. that is uyt plus of ayt square divided by uxt plus of axt square of axt square. So this is what? Pi, angle of elevation. So pi equal to tan inverse of sy by sx. So angle of elevation pi equal to tan inverse of sy by sx. So this is the angle through which particle gets elevated above the ground at that given instant, right? That is what? Tan pi. Okay. So here what is the reference? 2D motion is nothing but a combination of two 1D motions which are mutually perpendicular to each other. One is along x-axis, another one is along y-axis. X-axis along y-axis in terms of velocity as well as displacements. Okay, very simple to understand, right? Now let us see one example. What is that example? Based on equation of trajectory. Equation of trajectory, right? Okay, equation of trajectory. Suppose for a particle which is in 2D motion, for a particle which is in 2D motion, its position vector changes. Its position vector with the time as r bar equal to at square I cap plus bt power 4 j cap. See, for a particle which is in 2D motion, its position vector changes with the time as r bar equal to at square I cap plus bt power 4 j cap. See here, t means nothing but time. So r depends upon time. Position vector changes with the time, right? Now find its equation of motion. Find its equation of motion and angle between velocity and acceleration. So we need to find angle between velocity and acceleration. Moreover, how to express its equation of motion, right? Now see the solution. How to solve here? Given vector is r bar equal to at square I cap plus bt power 4 j cap. Now r bar contains two components. One is along x-axis, another one is along y-axis. So usually that is r bar is nothing but sx into I cap plus sy into j cap. Otherwise xi cap plus y j cap. Now what is x component here? X, sx, either sx otherwise simply x, either sy otherwise simply y. So I am taking x. So x means what here? Positional coordinate, x positional coordinate, that is at square. Y positional coordinate, y equal to bt power 4. Okay. Now on differentiating with respect to time both, so you will get Vx here. Vx means x component of velocity, that is dx by dt. What is the differentiation with respect to time here? A into 2t, that is 2a. Right? Here Vy becomes equal to dy by dt, that is equal to b into t power 4, differentiation with respect to time, 4tq, that is 4btq. Right? Okay. Again on differentiating with respect to time, dv by dt means acceleration. So as it is x component of velocity, you will get the x component of acceleration. That is ax becomes equal to dvx by dt, right? That is 2a into dy dt of t means 1, that is 2a. Similarly, y component of acceleration, that is equal to dvy by dt, right? Now 4b into dy dt of t means 3t square, 3 4 jar, wow, 12b t square, 12b t square. So these are x and y components of velocity, these are x and y components of acceleration, right? Okay. Now what is net velocity here? Root over vx square plus vy square. What is net acceleration here? Root over ax square plus ay square, right? Now see here, y equal to what is that? Y b into t power 4, right? B into t power 4, that is same can be written as b into t square whole square, b t power 4, that is b into t square whole power 4, that is t power 4. What is t square here? T square means here x by a. See, this word number 1, this word number 2, right? That equal to b into t square means what? From expression number 1, t square equal to x by a. See here, t square equal to x by a, that is x by a whole square. Since from 1 implies t square equal to x by a, so t square means x by a. Now y can be written as b x square by a square, b x square by a square. See, this is what equation of trajectory. Why? Because x dependent of time, y also dependent of time. So both are time dependent. Both x and y components are time dependent. But here y is a function of x without any involvement of time in this expression. This is what, if x and y coordinates relate each other without involvement of time in that expression, then that becomes equation of motion. Usual, what I said in previous session, that is what y equal to bx square by ax square. Y is a function of x, but there is no involvement of time here. So this is what required equation of trajectory. Equation of trajectory. Okay, right? Equation of trajectory means there must be relation between x and y without involvement of time. That's what equation of trajectory. So one question is over. So what is the other question? Angle between velocity and acceleration. Here velocity means, for velocity we have two components. We have to set for one component, one unique value, that is v equal root over ax square plus vy square. That's what v. What about a? A also equal to ax square plus ay square. Now see, let us see. V equal to root over bx square plus vy square. Right? From previous session, what I said, v is the combination of two mutual perpendicular components. So what is the net value root over vx square plus vy square? Naturally, that is vx square plus vy square. Vx square means vx square 2a whole square, that is 4a square. 4a square t square plus vy square. Vy means 4b t cube. 4b t cube whole square, that is 4 is 16 t square, 16 t square t power 6. This is what net velocity. Coming to net acceleration, in the same way, a equal to root over ax square plus ay square. So a equal to root over ax square plus ay square, right? That is what ax square plus ay square. Ax means 2a, 2a square means 4a square. 2a square means 4a square plus ay means what? 12bt square, that is 4 on squaring 144 b square t power 4. 144 b square t power 4. This is what net acceleration. So we have expressions for net velocity and net acceleration. Now what is our task now? To find angle between these two vectors. Of course, both velocity and accelerations are vectors. If you want to get angle between given two vectors, how to get angle means by taking dot product. We have cos theta between V bar and A bar equal to, what is that cos theta? That is V bar dot A bar by mod V bar dot mod A bar. Right? By definition itself, we know that A bar dot B bar equal to A mod B cos theta. Alright? See? A bar dot B bar equal to mod A bar mod B bar cos theta. Cos theta means cos theta equal to A bar dot B bar by mod A bar mod B bar. So in the same way, V bar dot A bar equal to mod V bar mod A bar cos theta. So cos theta equal to V bar dot A bar by mod V bar mod B bar. That's what written. Okay. Now what is V bar? V bar. What is V bar? V bar dot A bar. That is V bar means, see, V bar Vx into I plus Vy into j. Vx into I plus Vy into j. See Vx, Vy. Right? Okay, that is Vx into, that is cos theta equal to V bar means x component into I cap plus y component into j. X component means 280. That is 280 I cap plus 4bt cube j cap dot A bar. A bar means what? See, x component 2a, y component 12bt square. That is 2a into I cap, 2a into I cap plus ax into I cap plus ay into jk. Ay means 12bt square. 12bt square j cap whole divided by mod V bar. Mod V bar. See, this is what mod V bar. V means this one. Mod A bar means this one. So mod V bar means this one. That is mod V bar here. This is what mod A bar. Mod V bar means root over 4a square t square plus, see, 16bt square, 16b square t power 6 into root over mod A. This is what mod A. Mod A, right? Mod A means 4a square plus 144 b square t power 4. Right? B square t power 4. Now that is cos theta equal to cos theta. See here I dot I 1. That is 2a into 280. That is 4 2a into 280. That is 2 2 ja 4 a into a square t plus j dot j1. That is 12bt square into 4bt. Okay, 4 12 ja 48 t power 5 whole divided by root over 4a square t square plus 16b square t power 6 root over 4a square plus 144b square t power 4. Right? Okay. So this is what cos theta. Now what is theta means? Theta equal cos inverse of. Theta can be written as theta equal to cos inverse of so and so. So this is what theta, angle between velocity vector and acceleration vector. Right? Acceleration vector. Right? What is sorry? Here what is a mod A bar here? Mod A bar means this one. Okay. Right? Okay. So V bar dot A bar. Complete. V bar dot A bar. V bar means Vx into I cap plus Vy into j cap. A bar means Ax into I cap plus Ay into j cap. Divided by mod A bar, mod V bar into mod A bar. So that's how one can find the angle between velocity vector and acceleration vector. Now let us see. Special cases of 2D motion. Special cases. What are the special cases here? Projectile motion and circular motion. Special cases. See here special cases. Special cases. Projectile motion. And circular motion. Both projectile motion and circular motions are the special cases for motion in 2D, right? So in case of projectile motion, the path is parabola. Path is especially parabola. Curved path means here especially parabola. When it is circular, path is circular. Your path is circular. So these two are special cases as far as 2D motion is concerned. Now let us see what is meant by projectile. When do we say that a given moving particle is projectile? Means here there is a specific definition for any particle to become projectile when it is under motion. What are the specific conditions? Means here when the particle is projected with some initial velocity other than 0, right? Here particle must act upon by some constant force. See, suppose this was some constant force like that, right? See, particle must be acted upon by some constant force. For example, constant force, and it is projected with some initial velocity, non-zero velocity, right? Such that angle between these two, theta, must not be 0, must not be 180 degrees, right? So especially the angle between these two vectors, that is between initial velocity vector means velocity of projection vector and constant force acting on the particle. So the angle between these two must not be 0 and 180, right? It can be between 0 and 180, means theta must lie between 0 and 180, but not equal to 0 or 180. If it is 0, it becomes freely falling. Otherwise, suppose one particle is dropped freely in the presence of gravity, then Fg means constant force. Fg constant, right? Dropped means your U0. Dropped means U0. U does not exist, means initial velocity 0. So here it is not example. Now suppose particle is projected vertical upwards above the ground. Now it is subjected to gravitational force vertically downwards. Now what is the angle between these two? 180 degrees. U upwards, Fg downwards. Here Fg of course constant at a given place. Constant, right? Here angle between U and force, gravitational force. Angle between initial velocity and gravitational force is 180. Right? It's not at all projectile. Why? Because this is a vertically projected body. It could not be a projectile. Of course, here particle is projected downwards here. Projected downwards, not equal to 0. Initial velocity not equal to 0. Projected vertically downwards, and is acted upon by constant gravity. That is constant. Fg is constant. Now, this also not example for projectile. Why? Because this is vertically, the body projected vertically downwards. It couldn't be projectile. Why? Because here, what is the angle here between these two? U downwards, FG also downwards. So theta equal to 0 degrees. So here theta 0, here theta 180. So these are not examples for projectile. Projectile in the sense, particle must act upon by some constant force, and when it is projected with some initial velocity, such that making an angle other than 0 or 180 with that constant force which actually acts on the particle, then that particle is said to be projectile. Then its motion is said to be projectile motion, right? Then its path is parabola. So especially in this condition, for any angle between 0 and 180, see here, for any angle between initial velocity and constant force acting on the particle, for any velocity between these two except 0 or 180, path is parabola. Path is curve. What is that curve? Especially parabola, especially parabolic path. Now we can realize the same in these diagrams. See here, first example. What is the condition? U, suppose it is constant force. Here U not equal to your initial velocity. Here theta not equal to 0, not equal to 180, but 0 less than theta less than 180, right? So as that condition is concerned, we have some examples. Suppose this is the level ground. From this ground, one particle is projected like that. Now, because of gravity, it won't go along the direction in which it is projected, right? But because of gravity, it takes parabolic path. Now, see, this is what U, right? This is what initial velocity, direction of initial velocity. Now, what is the gravitational force acting on the particle means? See, this is the initial velocity. Now, this is the direction of gravitational force, right? Gravitational force. This is what constant at a given place. It also non-zero initial velocity at theta. This is what theta. See, here it is U. Here it is FG downwards at any position on the curve, right? Okay. Now coming to second case. This is what one tower. From the top of the tower, particle is projected horizontal line. It's some non-zero initial velocity, projected horizontal. But particle never goes along horizontal, even though it is projected especially along that direction. But because of gravity, it takes parabolic path line. See, this is what path followed by the particle. In this case, this is what path followed by the particle, right? Now, assign the velocity vector, initial velocity vector and gravitational force acting on the particle. See, this is what initial velocity vector, Fg downwards. Of course, at any position on the parabola, gravitational force acting on the particle is always vertically downwards one. It is lying somewhere here or somewhere here, whatever it is. Fg always downwards. Now, what is the angle here? Theta 90 degrees. So, satisfied. Condition is satisfied. Here theta less than 180 degrees. So here also condition is satisfied, right? Now coming to third example. Suppose here is what a tower of certain height. Now from this top, this time body is not projected along horizontal but projected such that making some angle with the horizontal level. See, this is what level of projection is projected from its top, but such that making an angle theta with horizontal. So because of gravity, it never goes along this way. Because of gravity, as body is pulled down because of gravity, it takes parabolic path. So it reaches level of projection and continues below the level of projection until it strikes the ground. Until it strikes the ground. See, this is what ground. See, this is the path followed by the path, right? So in this case also, see, this is what velocity, this is what Fg. Fg downwards. And the particle gravitational force is downwards. Initial velocity projection is like that. So what is the angle here? Theta less than 180, more than 90. Less than 180 and more than 90. Here also more than 90. So condition satisfied, right? Now coming to one more example, fourth one. This time body is projected up the inclined plane from its bottom as shown. See, this is what inclined plane. This is what one inclined plane. Here particle is projected from bottom like that. Projected like that. But because of gravity it takes parabolic path and strikes the inclined plane somewhere here, right? This is the path followed by the projectile. This is also example for project. This is what inclined plane. One body is projected up the plane, up the inclined plane. Projected up the inclined plane, right? Okay. Right? This time, see, this is what initial velocity. This is what Fg. Fg. Now theta greater than 90, less than 180. Less than 180. Greater than 90, less than 180. So condition is satisfied. So in the same example, if body is projected down the inclined plane from stop. Number 5. See one more example like right. This is what one more example. Here this is what one tower. Sorry, on inclined plane. Now from its top, one body is projected like that. Projected with some initial velocity like that. So because of gravity, it takes parabolic path and strikes the inclined plane somewhere here, right? Okay, so here also, what is the direction of initial velocity? This is the direction of initial velocity. Here, gravitational force acting vertically downwards. So here, what is theta? Theta is greater than 90, less than 180. So theta lies between 90 and 180. Okay, so these are some examples for projectiles whose paths are parabolas. Parabola, here also parabola, parabola, like that. Right? Now let us see here. What is meant by parabola? Different shapes, different possible cases of parabolas. Parabolas. See, parabola, next point. Parabola, right? Okay, there are two forms are there. First one, y square is proportional to x. See, x and y are nothing but positional coordinates. Here y square is proportional to x. Y square can be written as plus or minus 4ax. Here x square is proportional to y. X square can be written as plus or minus 4a into y. Now see here positive side and again negative side. So here two cases, here also two cases. One with the positive sign, another one with the negative sign. Now let us see. What is the shape of parabola for y square equal to 4ax? I'm taking x and y axis like that. See, this is what x dash, y dash, y dash. X dash, y dash. Now y equal to plus 4ax. y equal plus 4ax means this is the shape. This is the shape, right? Here it is focus. It is focus with coordinate a comma 0. A comma 0. Here it is vertex. Here it is vertex, which is nothing but origin 0, 0. V stands for vertex to be taken as origin. Here the center point focus with coordinates a comma 0. A means here nothing but distance between V and F. The distance between vertex and focus is nothing but A. So that's what A in the expression, right? Now here F lies on the positive x-axis at some distance A from the vertex. So therefore, definitely this is the equation of, what is the equation of this parabola? Y square equal to plus 4ax. 4ax. If focus lies on the negative x-axis at the finite distance A from vertex, then that becomes minus 4ax. See, this is what example for that one. X, y, y dash, x dash. Now see, this is what parabola. I am writing parabola somewhere here with focus lying on negative x-axis at finite distance A from the vertex 0, 0, vertex 0, 0. This is what focus. What is the distance of focus from vertex means A only, but as focus lies on the negative x-axis, it becomes minus A and y coordinate 0, right? Now definitely what is the expression for this one means this parabola y square equal to minus 4ax. So this is what y square equal to minus 4ax. Now coming to this one, x square equal to plus or minus 4ay. Let us see first x square equal to plus 4ay. See, first example, x dash, y dash. Now see here, x square equal plus 4ay. Y. Here y means focus lying on positive axis. Like that. See, this is what required parabola. I am writing somewhere here on the positive y-axis with the focus lying somewhere here with the coordinate A from vertex 0, 0. So vertex means 0, 0 origin. From this vertex, what is the distance of focus on positive axis? A. So your coordinates 0, comma A. X coordinate 0, y coordinate A. Right? Now definitely, what is the form? X square equal to plus 4ay, right? Now coming to last one, x square equal to minus 4ay. X square equal to minus 4ay. So x dash, y dash like. Now this time I am taking parabola on the negative y-axis like. On the negative y-axis like. Okay. Now this is what vertex, which is nothing but origin 0, 0. Here it is focus. Here it is focus point somewhere here. Focus. What is the distance of focus from the vertex origin? That is A. But as it is lying on negative axis, it is minus A. So coordinates 0, comma minus A. X coordinate 0, y coordinate minus A. Right? That is what x square equal to minus 4ay. See here, 4a into plus y, that is 4y into plus a, 4y into plus a, here 4y into minus a, here 4x into plus a, here 4x into minus a. So these are some parabola equations. Okay friends, with this I am concluding. So in the next video onwards, we are focusing strongly on oblique projectile. So until then, bye. Thank you.